right, guys, here we go. Note 17, linearization. All right. So, all right. You're funny, miss. So, this LX deal, that just stands for linearization. Don't worry too much about notation. All that right there is just a tangent line. That's all it is. So it says if f is differentiable at x equals a, then the equation of the tangent line, blah, 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 defines the linearization of f. Here, these two are yours. Linearization of f at a, the approximation f of x equals L of x is a standard linear approximation of f at a. The point x equals a is at the center of the approximation. So people use the L of x just to say that they're using that tangent line to find the approximation of your f, but you can only use this. All right, let me give you a visual. So, and don't worry, I'm going to write it right here, but I'm going to erase it because this is an example. So this is what's happening. I have a curve. I don't know the equation of that curve. Well, I guess we do, but let's say I want to know, so here's my tangent line. And if I zoom in, do you see how if I zoom in, this curve and that line look like they're practically the same? So if I want to figure out what the value is, the approximate value of this curve is right there, you can use the tangent line to give you a pretty good approximation. Does that make sense? Now, the farther away you are from point of tangency, then the worse your approximation is going to be. Like if I get my approximation for the y value right here of the curve, well, look at the gap. Look how big it is. That error is. Does that make sense, guys? Now, I will agree that this, like, child, when am I ever going to use this? You're right, because now we have calculators that can figure out the point at any curve now, Desmos and all that good stuff. But all those tools that you use to find those approximations, how do you think it finds those values? It might be using, in MATLAB, there's something called scripts, and you create scripts. It might be using the same logic that we're doing right now, right here. Isn't that cool? Okay, so check it out. Without a calculator, and then we'll see how close it really is. Do you guys have your calculators with you? Okay, so check it out, guys. We're going to go slow. Find the linearization of f of x equals square root of x at x equals 4. That just means find tangent. Find tangent. Find tangent line. That's all it means. Bless you, bless you, bless you, bless you, bless you, bless you, square.
Bless you, stop it.
Oh, okay, okay. So at x equals 4, the square root of 4 is 2. So I have a 0.42, and now I need a slope. So I'm going to write f of x equals x to the 1/2. I'm not doing anything. I'm just taking a derivative. I'm just finding my slope. I'm finding my tangent line, guys. F prime of x equals 1/2 x to the negative 1/2, which is 1 over 2 square root of x. Nothing crazy. My slope at 4 is 1 over 2 square root of 4. So square root of 4 is 2, 1, and 2 times 2 is 4. So then I go y minus 2 equals 1/4 x minus 4. And if I'm using linearization, if I'm using their, the way they want me to write it, that's fine. L of x. It's not a big deal if you write it like this or not. 1/4 x minus 4 plus 2. This will give me a really good approximation for the square root of x, but only around x equals 4. The further away you get from x equals 4, the worse this approximation is. Obviously at 4 it's going to be perfect. The square root of 4 is 2. But, so do we understand what we're doing? We're not robots. This will give me a really good approximation for values really close to x equals 4. Cool or not cool? Okay, so it says, and use it to approximate f of 4.02. Well, this is square root of x. This is my x value that I'm going to approximate. X equals 4.02. So let's see what it is. So I'm going to write L of 4.02 equals 1/4 of 4.02 minus 4 plus 2. So let's see. 1/4, let's see, 4.02 minus 4, isn't that 0.02? Plus 2. What is 1/4? What is 0.02 in fraction? It's not 210. I think it's 2 over 1 over 50, 2 over 100, which is 1 over 50, plus 2. So let's see. 50 times 4, that's 51, 152, so 200. So 1 over 200 plus 2. So I'm going to put that 400 over 200, that's 2. So 401 over 200. That's my approximate. F of 4.02 is approximately 401 over 200, which is, let's see what that is in decimal. 401 over 200. 2.005. Let's see how close that is to the exact. Use the calculator to determine the accuracy of the approximation. Okay, let's see how far away. Let's see how far away from exact. Okay, square root of 4.02 is, let's see what it is. Square root 4.02. Look at that, guys. So if I take this number and I subtract the 2.05, obviously it's going to be negative because the 2.05 is larger, but it is, let me see, push enter. It is 0.00006. Did I say 5 zeros? 234 away. 6.234 times 10 to the negative 6. Negative 6.234 times 10 to the negative 6. And this was 2.00499. 2.00499. And the difference between that, the difference between 2.00499 and 2.005 was this number, which means negative 0.123456234. That's how far away they were. That's a pretty good approximation, no?
Yeah.
You guys aren't impressed?
No, we are.
That's how they did it back in the day, guys. Without a calculator.
Wait, what was the race? Exponent?
Well,
Negative.
-6. It just got blocked there. Yeah. All right. So we're doing the same thing here. And I'll show you how it looks in the AP exam in a little bit. And then we'll do some samples. It says, use linearization to approximate square root of 123. 123 is really close to a perfect square root. What's the closest perfect square root to 123? 121. So I'm going to say y equals square root of x. You're right. And I'm going to use 121 comma 11 because the square root of 121 is 11, right? All right. So here we go. Bless you. Bless you. So again, I'm just going to have y prime equals, and then we already did this. We did this already over here, guys. That's the same equation with square root of x. So 1 over 2 square root of x. Is everyone okay with how we got that? Okay. Y prime evaluated at 121 is 1 over 2 square root of 121. 1 over 2 times 11. 1 over 22. I don't see any mistakes. So my tangent line, how much space do I have? Okay. My tangent line, y minus 11 equals 1 over 22, parenthesis, x minus 121. There's my tangent line. And this is what I'm going to use to approximate. They want to know the approximate of 123. So I'm going to plug in 123 in there for 121 for the x. So here we go. Y, my approximate y is going to be equal to 1 over 22 times 1. I guess I'll write it out for now because we're rookies. Times plus 11. So I'm just going to type that in. So if f of x is square root of x, I'll just say it. I'll just write it. So approximate square root of 123 is, and then let's see what that is. I take my calculator. I guess if you're using a calculator, it defeats the purpose of doing this right here, right? Because you can just type in to get the exact. 1 over 22 times, is it 2? Yeah, 121, 123. Times 2, and then plus 11. Plus 11.090909, and it repeats forever. So that can turn into a fraction. 122 over 11. 11.09 repeating forever. Let's see how close of an approximation that is, guys. So the square root of 123 is exactly, let's see what it is. Square root of 123. So look at that, 11.0905. So I'm going to take this number and I'm going to subtract my approximate value. It's 0.00037 away. That's pretty good, no? Yeah, that's pretty accurate. All right, let's do something exciting. So this one says cube root. What's the closest? Relax. So I have a function, and it's the cube root of x. What's the closest perfect cube root to 123? I know you guys know. No, do we know our cube roots?
Well, I was thinking like, okay, 8 times 8 is 64.
Yeah, that's way big. Okay, let's see. 2 to the third is 8. 3 to the third is 27. 4 to the third is, yeah, someone already said 5 to the third. Right? So 125 times 5, 25, 25 times 5, 125. So f of 125 equals the cube root of 125, which is 3. So there it is. That's where we're going to get our tangent. We're going to find our tangent at 125, 3. Are we okay so far? All right, here we go. I'm going to take a derivative, so I'm going to write f of x equals x to the 1/3. I haven't taken a derivative yet. I need my slope. F prime of x equals 1/3 x to the what power? Negative 2/3. So this goes to like this. 1/3 the cube root of x squared. Child, I don't know if I'm going to be able to do this. Relax. Look. F prime of 125. We're going to go slow. 1/3 cube root of 125 squared, which is 125 times 125. Are we okay so far? I haven't done anything crazy. I know that the cube root of 125 is 5. And look, I got a perfect set here. Group of 3, group of 3. So this right here that I'm circling just becomes 5 times 5, which is 25. And what's 25 times 3? So there it is. 1/75. So now I'm going to go my approximation. I'm just doing my tangent line. Y minus 3 equals 1/75 parenthesis x minus 3. Hopefully no one's confused. All I'm doing is tangent line. Oh, you're right. X minus 125. Thank you, miss. I would have gotten it wrong. I was checking to see if you were listening. Yeah, no, I make mistakes. I make mistakes all the time. All right. What am I going to plug in right there? What do I want to know? 123. The approximate. So y equals 1/, well, I guess the approximate. I guess I'll write it like this. So square root of 123 is approximately 1/75 times 123 minus 125. What's that? Negative 2 plus 3. Oh, yeah, the cube root. Okay, what happened?
Root of 125 is 5.
Yes,
So why did you put
you're right. Damn.
Wait, I'm confused. That wasn't mine.
Yeah. Look. Yeah. That's why you guys gotta fix me, guys. Look. Don't worry, we're fine. Look, it's not gonna mess up our stuff that much. This is a 5, so change that to a 5. And then let's see, did we make a mistake anywhere else? We said it was 5. We got that. See, we got this one correct, but yet we got this one wrong. How funny is that? And then, so y minus 5, change that to a 5. And that's a 5. And there. I don't see any other mistakes. I think we fixed all our issues. Yeah, we did. You don't trust me? You said you don't trust me? No, I think we're done. We'll see how close it is. So, negative 2 over 75. Negative 2 over 75 plus 5. So, 4.97333.
Negative?
Why would it be negative?
Oh, wait. No, wait. You're right. My bad.
All right, here we go. So let's see what the cube root of 123 really is. Cube root. Oh, I gotta push math then. Math, this one, of 123. Look at that. It's so close. That minus. There's 0.0001 away. That's pretty close, guys. So as long as we're really close to the center, to our point of tangency, we're going to get really close numbers. So yeah. All right. Here we go. Before I continue, do you guys know how to find error from your science days? No?
I don't think so.
Okay.
Maybe.
Yeah.
In what sense?
Like, how do I find percent error for anything? Yeah, like, how do I find... Do you guys remember?
We definitely do. Did we learn that?
It's just logic. Like, maybe in science class, science lab, when they're like, what's the error?
We've had a few science.
Yeah, maybe 8th grade science, maybe physics, maybe chemistry. Yeah, margin of error. Margin of error might be variance or might be like...
Give me like a timeline. The margin of error. What is the percent timeline? I don't know. The amount you can overshoot and the amount that you can undershoot.
And then divided by the actual?
Divided by
the error.
Amount of possibility.
Wait.
You're close.
Okay.
All right.
Let's think. Okay.
Yeah, let's go right into it, guys. Let's go right into it. Percent error is absolute value of your error divided by actual times 100 will give percent error. Yeah, biology. Yeah. But what I'm trying to say, guys, is that it's nothing crazy. It's just if you use your logic, if you figure, like if you just use a little bit of, you'll be fine.
Oh my god.
Okay. So here we go. So this one requires a calculator. You couldn't do this one without a calculator. So let's see. The linearization y equals cube root of x at x equals 64 is used to approximate the cube root of 66. So they're already telling you where they want the tangent line. I'm going to put here, find tangent at x equals 64. What is the percent error? Okay, ready? What is the cube root of 64? You have a calculator, so you don't have to do it by hand either. So 64 comma, no, it's 4. The cube root of 64, but just in case, look, you could have done it 3 ways. You could have pushed math number 4 and then put 64 in here. So let me show you all 3 ways. Enter. You could also do it like this. You push math, you push the number 5, and see it gives you a little blank here, and you push the 3rd root, because that means you can do any root. Yeah, your calculator is powerful, guys, and put 64. There's another way. If you don't want to use that, you can just go like this. 64 to the power, parenthesis, oh, actually, you don't have to, because it gives you a little block there. 1/3, and then push enter, and there it is. There's so many different ways to get this answer. Are we cool, guys?
Yes.
Okay, making sure. All right, here we go. So there's my point. Now I'm going to find my tangent line. So f of x equals x to the 1/3. I already did this derivative earlier. f prime of x is equal to 1 over 3, and what did we get earlier? Cube root of x squared. Cube root of x squared. So I'm going to write f prime of 64 equals 1 over 3 cubed root of 64 times 64. Well, that we already said was 4. And this one is also 4. I know you could use your calculator because you have a calculator. 4 times 4 is 16, and 16 times 3? 48. 16, 32, 48. 32, 42, 48. You also have a calculator, guys. So you can use a calculator. Okay. All right, guys, here we go. I got my slope. Let's find what this value is. So I'm going to write f. What am I looking for? Or the linearization. Oh, it doesn't matter. F of 66 is approximately, so it's not going to be the most accurate. I'm taking a shortcut here, guys. I hope that you guys are okay with it, but if not, let me know. X minus 64. Close it. I need to put a 66 in here. So 66. And then on the outside, plus 4. Are you guys okay with that, or did I lose you guys? Yeah. In case I lost you, in case you don't want to say, it's my tangent line. Y minus 4 equals 1 over 48, x minus 64. And all I did was move the 4 and plug in a 66, and that gave me my answer. Now, this is not the answer, this is because they want % error. So I'm going to write 1 over 48, parenthesis, 2 plus 4. If you don't like this, guys, if you feel like this is you're prone to make an error, then use a little fraction feature like this. 1 over 48 and then times 2, or what was it, 66 minus 64, and then whatever that is plus 4. You can always do it like that. Oh, by the way, that is this decimal here. Watch. 97 divided by 24. You can tell the calculator to give you a decimal. It's up here. That MP stands for math print. Okay. Are we okay? Let's see what the real value is of the cube root of what? So cube root of 66. I push enter, and I'm going to find the difference between those two. It's a very small percentage. So here we go. I'm going to go minus. And yeah, I like what someone said. You can store it into a register. This is the approximate one. So I'm going to subtract that one. So there it is. That is my error. That is this. That is my error. So absolute value. So what was my error again? 4.266 times 10 to the negative 4. 4.266 times 10 to the negative 4. I didn't put a negative because it says absolute value, right? And I'm dividing that by the actual. So here we go. I just take that number and I divide it by the real one. So I'm going to go again, math, cube root. Have I lost anyone? So there it is. I'm dividing by the real one. Guys, I'm just finding the % error. Dividing by the cube root of 66. I push enter and I'm almost done. That's not a percentage yet. All I got to do is multiply that by what? By 100 times 100. Now it's a %. Look at how small my % is. Take away the negative. What's my percentage? My percentage error. No, it's not 1%. This is already a %. 0.01%.
So when you multiply it by 100, it's not times 100%. It's just times.
Well, it times 100 turns it into a %.
Yeah, but it's not the percent itself.
I guess I should have deleted that. Times 100 will give you the percentage. You know what I mean? Yeah, because then the % itself is like 1, so it's going to be the same. You know what I'm talking about or no? Okay. How do we feel, guys? Okay. Yeah, when you multiply by 100, it gives you a %. In case you're wondering, in case, because I see some of your faces like, Chav, I would never know how to do that by hand. Okay, look. If you take a test, and there's 10 questions, and you get 7 correct. I don't want to know your grade. I want to know your error, your % error. Well, if you got 3 wrong, look at this. There's 10 questions. Well, actually, no, I said percent error. 3 wrong, 3 over 10. Multiply that by 100. Maybe that's a bad example. And that's 30%. And that's a 30% error. And you guys can do that, right? Okay. Or maybe I should have said, find what's your average if you get 7 correct. 10 minus 3, the wrong ones, divided by 10 times 100, 70%. I don't know, kind of similar to that. Okay. Maybe these are bad examples, and maybe I shouldn't have used that. Okay. Here we go. Oh, thank you, miss. Appreciate it. All right. All right, here we go. Focus, guys, focus. This is from a real AP exam. You just got started. 57%. It's not part of your 2008 exam. This is from a recent one, international. 57% of the total population got it correct. I don't have the breakdowns of 3, 1s, 2, 3, 4s, 5s. Do you guys want to give this a shot? This is no calculator. Do you want to give it a shot and see if you can get it right? Try it out, guys. Try it out, guys. Try it out.
Okay. Can you give us like a little while?
Yeah, a minute.
That's not a lot, Charles.
On the real one, you have an average of 2 minutes a question.
That's double the time.
No calculator. I was about to grab the calculator.
I'm going to turn on the AC on the other one. I'm sorry, miss. I need to stop bullying.
I don't like that. Me neither.
You don't got an answer?
1.5 is 3 over 2.
Yes.
I don't know why that
Do you guys want me to start?
No.
All right.
No.
Okay, keep going then. Keep going.
Let me
I'm trying to figure it out.
What'd you guys get? All right. Here we go, guys. It's not as hard as you think. Find a tangent line first. Get tangent at what value? At x equals pi over 2. So find the tangent line. What do you need for a tangent line? Point and slope. Are we cool with that? All right, so here we go. F of pi over 2, so here comes pre-cal. It's baby pre-cal. 2 cosine of pi over 2 plus 1. What's cosine of pi over 2? No.
What?
Cosine of pi over 2.
Pi over 2! Oh my god!
0. 0 times anything is 0 plus 1. So my point is pi over 2 comma 1. Are we okay so far?
Yes.
Now I need to find a slope. I find a slope by taking a what? So here we go. F prime of x equals the derivative of 2 cosine x. No. Negative 2 sine
I
x.
just chain roll for no reason.
Yeah, there's no chain because it's to the power of 1. Are we okay so far? All right, so here we go. I'm going to plug in pi over 2. F prime of pi over 2 equals negative 2 times sine of pi over 2 is? Not everyone at the same time. Sine of pi over 2 is 1. And 1 times negative 2 is just negative 2. All right. I got my point. I got my slope. Here's my tangent. Y minus 1 equals negative 2 parenthesis x minus pi over 2. This is my tangent line at pi over 2. Sometimes they call the y the L of x, linearization, because that's the line you're going to use. 1.5 is really close to pi over 2, so it should be a pretty good approximation. So this is what I'm going to use. You guys ready? I'm going to plug in 1.5 in here for x. Now, instead of writing 1.5 in there, what do you think I'm going to put? 3 over 2, because I already have a denominator of 2. Do you guys see that? So here we go. I'm going to write, let me see, what am I going to write? I'm going to write f of 1.5. F of 1.5 is approximately negative 2 parenthesis 3 over 2 minus pi over 2 close plus 1. All I did was move the 1 to the other side, and I called y f of 1.15. Are we okay with that? All right, let's see what we get. So I'm going to have negative 2 parenthesis 3 minus pi over 2 plus 1. Does everyone know what I did there? My denominators were the same, so I grouped them. When I distribute that 2, what happens to the 2 in the bottom? It goes away, but we still have a negative on the outside, so change the polarities. Change the polarities. So here we go. I'm going to write pi first. So I'm going to write pi, and I'm going to write minus 3 plus 1. Are we okay so far? What's negative 3 plus 1? So pi minus 2. I don't see any hiccups. I think we are good. Is there an answer of pi minus 2? Could you have done that? We need experience, but we can do this.
I was thinking of pi before. I was like, I don't know what to do with that plus 1.
Yeah, we just need experience, guys. That's it.
I see the process now.
Okay, here we go. So these are similar to delta. So I think that's where the idea came from. It says let f be a differential function such that, and I have a point, and I have a slope. What is the approximation? As long as you're really close to the negative 5, this approximation should be good. Found by using the line tangent to the graph of f at x equals negative 5. Okay, first, someone told me to write steps. So here I am, doing it for you guys. I'm writing steps. First, find tangent. Find tangent. So here it is. Y minus a negative 2, so it turns to a plus. You might want to write negative 5 comma negative 2 like that. Equals, what's my slope? 9 parenthesis x plus 5. That's my tangent line. Second, use tangent to find approximation. All right, here it is, guys. I'm just going to move the 2 to the other side. What am I going to plug in for x? Perfect. So I'm going to write f of negative 4.85 is approximately 9 parentheses negative 4.85 plus 5, close it, minus 2. So let's see, what is that? 9 times negative 0.15 minus 2. 0.15 in fraction. Just use a calculator. What is that?
It is negative 3.35, like all of that.
That's it, right? Negative 3.35. And it doesn't go on forever? Just.
No.
Okay. And a mosquito bit, you guys.
Low help.
Wait, why it's negative? Why is it negative 1.5 plus 5 minus 11?
Say it again. Oh, yeah, you're right. Mistakes galore. Sorry, guys. I haven't been having I mean, I've been having an okay day, but I guess I've just been making mistakes.
Okay, now it's -0.65.
Negative 0.65. How do we feel?
Tired.
Okay, let's see if we can do the next one without a mistake.
Oh, heartburn.
All right, here we go. I'm going to try really hard not to make a mistake. As a matter of fact, I'm going to read it carefully this time. Let f be differentiable function such that I got my point, and my derivative is that. What is the approximation of negative 2.05 using the line tangent to the graph of f at x equals negative 2? So I have my point. Now I got to find the slope at negative 2. So here we go. F prime of negative 2 equals 5 times negative 2 plus 5. So that's negative 10 plus 5. So I see negative 5. Have I made any mistakes? Okay. Y minus 3 equals negative 5, parenthesis, x plus 2. I think we're still in the clear. Right? What am I going to plug in for this x? Negative 2.05. So I'm going to write f of negative 2.05 is approximately negative 5, parenthesis, negative 2.05 plus 2. I guess you could have also written just negative 0.05 plus 3. So what do we get there? $3.25. All right, and there it is. I don't see any errors. I think we're good. Yeah. That's 0.25, negative times the negative, 3 plus 0.25. Yep, good job. How do we feel? Okay. All right, we will come back to this problem. That's because we don't know, you guys don't know what the second derivative means in terms of f. Or maybe you do, I don't know. No? Okay. We aren't ready for this just yet until we talk about f prime, f double prime. Hopefully we can get there before gobble gobble. What does, you know what f prime means? F prime means the slope of f, right?
Yeah.
So f prime means the slope of f prime, which, what does it mean in terms of f?
Prime of f.
Yeah, we'll talk about that when we get there. Don't let me forget to add this question once we talk about f prime, f double prime. That's what we're going to talk about next, hopefully tomorrow. So yeah, guys, take care of the delta. There's a delta. You're just going to get better with approximations, and that's it. That's the only assignment you have today.
And then we also have our correction